Okay. All right. When you look at the module 1, these are the things that we're have covered up to this time. This is week 4. And so on Wednesday, we will have the test number 1 in here. And as I had said, there are just sequential. It'll be a problem that has just straight sequential statements, and it'll have input, and you'll have to come up with the variable names. And there may be, let's see, does anyone have any questions over this unit 1, number 8 problem? Because it may be similar to something like this. Yes, Sammy.
I have a question. Did you want us to do both of like a flowchart and a pseudocode? Did you want us to
Yes. Always on until I tell you different, always do both, even though it says or. Okay. So, and what I had some student ask me was, where was this problem? Well, these problems are all in the ebook on Cengage. So let me go here and just show you. So always, if I say unit 1, problem 8B, then it's going to be in the textbook. And so what I showed you there is that we did, or I gave you 8A, and so you only had to modify the pseudocode and flowchart that was given there in that problem. So let's look at it. And I was going to go over it today, but I did give everyone until Tuesday night, I think. Let me look on that to get it done. So I didn't want to give the answer. Let me see what it says. September 9th. Yeah, I think it's, I'm not showing it there. I should have went back to the home. Didn't it tell the due date on there?
Yeah, it's September 9th.
11, okay, so since I gave you till midnight tonight, I didn't want to cover it today in class. So, but I will cover 8B. I mean, I'm sorry, 8A, because I didn't we didn't have time to look at that. But if you look at what the problem was here, let me read the problem. Let's see, it's unit 1. Exercises. So not the review questions. Somebody asked about that. No, it's the exercises here. And if we look at 8A, said to draw a flow chart or pseudocode, which always I told you to do both. So that example that I gave you of 8A should have both in there, to represent the logic of a program that allows the user to enter an hourly pay rate and hours worked. And the program outputs the user's gross pay. So how many input fields are there? We did this, didn't we?
Yes.
Okay, so we did do this one in class. I think it may have been my 12:30. Catan, did we do that one in your class? 8. Yeah, we did that. Okay, so the only one you have to do is the part B. So that's going to output the net pay. And I'm not sure how many, I know some of you got it done. I just didn't get it graded. Of all the things that I did, I tried to get all of these graded. And I believe I got all the variables graded. So you should have grades for those items. And this was the only one that I didn't do because the due date wasn't up yet. And then we did this one and this one in class in here. We never got to this one, right? Is that right? No, then we didn't in yours. We did get to the, no. What about in the 930? Did we get to this class? This is the problem in MindTap. Okay, so this is one of the problems in MindTap. I think Jamie and somebody else, but we didn't get to it. Okay, so let's go into MindTap then, and we'll do this one together, arithmetic and assignment operators in Python. And before we start in it, first I'll ask, is there any questions about the test and what you will do when you come in on Wednesday? Yeah, and now you'll be in the 12:30, I guess, and take. Anybody have any questions? Okay, so you'll come in and test 4 will be available, and it'll be available till 11. So if it takes you longer than, but you're given 75 minutes, you'll actually have to leave the classroom because another class is in here at 11. But you shouldn't take over 75 minutes to do it. Usually students get done in 20, 30 minutes, okay? So that will, you will look at the problem, or you can print it out up here, whichever way you'll want it is easier for you to do it. And then you will submit the PDF document and the PY file like we did on 8B, okay? All right, so this one is the furniture.py. I was saying we did do this in the 1230 class.
This one?
Maybe not.
No, not this one.
Okay. Because I was going to put this one up because, oh, I think a student, was it a student in here that did it? Did you do it, Jamie? And you didn't have trouble? Anybody else in here do it already? You didn't have any problems? Okay, who else, anybody else do it? Okay, so if you did not do it, then you can do it with us here in class, and then you won't have to worry about if MindTap gives you some issues. So in this lab, you complete a partially written Python program that is provided along with the data files for this book, which was written for a furniture company. It prints the name of the furniture item, its retail price, its wholesale price, the profit made on the piece of furniture, a sale price, and the profit made when the sale price is used. So this problem right here is a little bit more complicated than what will be on your test 1 because it has a lot of output. You won't have that much output. But one thing that I want you to look at here that you will want to use on the test is how to print out $ and format money, okay? I think it's going to do that here. Let me see. Does it call it a float anywhere? No, I guess not. Oh, here it's multiplied by 0.75. Okay, this one is already done up on my screen. That's why I thought I did it in one of these classes. This is what is required. The file name is furniture.py. The file includes output statements. Read them carefully before you proceed to the next step. Design the logic that will use assignment statements to calculate the profit as the retail price minus the wholesale price. Okay, in this case, these variables up here are actually called, what kind of variables? They're given a value at the top of the programs, constants. And they aren't following the rule that we have. What do I like you to do when you define a constant?
Okay.
All caps. So this looks like a regular variable. So they're not using it as a constant. So they're just initializing the variable instead of asking for input. So it will work with it. Everybody will have the same answer. That's why they did it that way. They initialized. This is also called initializing a variable. So they're saying, make the item name. Do you all have these 3 already in yours? No?
Wait, which one? No, no, 3?
Do you have these already up there? Okay, but you don't have these, right? No. Okay. So this is the one that is for the profit, to calculate the profit. Profit would equal retail price minus wholesale price. And then it says to calculate the sale price as 25% deducted from the retail price. So why does it say 75% here when it says to deduct 25%? Why'd they do it that way? Yeah, well, what they're doing, instead of having 2 statements where you would have to calculate 25% and then subtract it from real retail price, they just said, well, 75% of the retail price is going to be the same amount, right? Does everybody see that? Yes.
So it'd be less complicated?
Yes, be less complicated that way. So when you see that it says calculate the sale price as 25% deducted from the retail price, that would take 2 statements to do it that way. Yes, Jamie?
I didn't do it in 2 statements. I did it in 1, but I did retail price minus and then in parentheses
Right.
retail price
Times that, yeah. So what Jamie's saying, if that makes better sense to you, you can do it that way. You could say in 1 statement, but it's still 2 calculations. So this way it's 1 calculation. And so if you don't understand what we're saying, please raise your hand, let me know, because we need to all be on the same page. So here, what you could say, if you wanted to go exactly the way the problem is written, then you would say, here's one way of doing it, how Jamie was saying. Sale price equals retail price, let's see, would be sale price first times 25%. So you would say, here, sale price. Is this how you did it, Jamie?
No, I did the retail price first.
Okay, you did do it first.
Yeah, I didn't sort retail price.
Okay, retail price times sale price. Oh no, it'd be minus, right?
Yeah,
Minus sale price times 0.25. So that's another way that you can do it. You can either do it this way or you could use that statement. Either one works. And so next you would say, it says to calculate the profit when the sale price is used. So the sale profit, and they give you each time the variable name that they want you to use. Sale profit is equal to sale price minus wholesale price. So here's the wholesale price. And then you would print the item name. And see, the way they do these print statements is something that you can always look up on Google if you're taking a test and you can't remember, or you can go into Cengage here and you can see it. Catherine, can you see that? I know it's hard back there. You guys back there, can you see it? Okay. So you can always put anything in parentheses. So the way they did the $sign here is they put it in the quotes. So that means it's going to just put a $sign there before it prints out the retail price. And you'll notice it puts string in front of it because it's a print statement. Sometimes it'll work without that. That's just how Python, since you don't define variables at the top, what data type they are, then when you print them out, anytime you print to the screen or to the printer, it becomes a string. It's no longer something that you're calculating with. So up here, we didn't want to say it was a string because we were doing calculations, right? But here we want to print all this out. So let's run it. Well, we can do our checks first. So if you do your checks, run checks, let's see. And it gave 100%. So now I want to see how my output looks. You don't have to if it gives you 100%, but you'll notice that it did change it to a float and put 0.75. But up here, there's a way that you can get it to print 2 zeros out. You can look that up on Google. I'm not going to show you right now, but you can do it by formatting it with a 2F. You can tell it how many decimals, but it's going to default here to 1 0 unless you format it and want 2 zeros there, okay? So if I tell you in your test to format it as a float, then the reason this one came out with a float is because of this decimal. It assumes that's a float, okay? Because can you see, which part are you not seeing, Caitlin? Can you see it now? Yeah. There, that helped. Okay. So, so it assumes I didn't have to do anything over here, but if you go out and actually there's a site, which people are still copying that, but I'll tell you there's a website called Stack Overflow, I think it is the one that shows you how to format for specific decimal points. So specific, like if you want it to be carried out 3 decibels because you're not doing money, then you can tell it to format it that way. So has everyone got this now? Everyone got this copy? Okay, so if I look over here, let me go to something where, oh, I have that open too. I don't know what that is. Okay, so if I go to, I just say formatting Python output. Let's see if showing results. Okay, so here's the web. Oh, this one's called Geeks for Geeks or something. There's so many websites now that'll show you different things. W3 Schools also. But here, and you can't see my screen, but here it tells you formatted string literals, Python program showing how to use string modulo operator. We haven't talked about that yet. Modulo operator is a division, the remainder of a division problem. So sometimes you may need what was left over. If say you divided 5 by 4 and you wanted the 1, then you would say 5 divided 5 modulus 4. He did talk about it in the video. Okay, good. Thank you, John. Let me know that. Okay, so here is if you're printing an integer value, the percent sign is like a placeholder. And it says, in this output, it says percent 240. So it's going to take this first percent sign and place 240 there. And then on this one, it's going to place 120. So the percent sign's a placeholder is what it is. So it shows you, it goes through that here too. So you can find all this information, however much you want to know about Python, you can find right here. And here tells you some interesting things, JavaScript versus Python. And when I talked, I think it was at the beginning of the semester, I told you about some job opportunities that if you go and search for programming jobs, there's a lot talked about full stack developer. And a full stack developer knows how to develop an application from the front end, which would be the website, knowing JavaScript and HTML and CSS, and then knowing database language like MySQL, and then also knowing Python. So there's a lot of people that are going in and getting their own training if you're good at doing that and becoming, I mean, some of them, if you look at some of the salaries, if you're good at it, you know, you have to be good at it to make a good salary. I know when I started teaching in the early 90s, and these classes would have a lot of students because they all heard if they learned how to program, they could make a lot of money. Well, only if you're good at it, you know. So when you start in a field, you know, after the first semester or so, usually if you have the aptitude to do that type of work. And if you do, then, you know, you can sell yourself in places and you know how to promote what your skill set is, then you can make good, you know, good money. And even people jumping into cybersecurity, yeah, there's a lot of money in that field. But you have to know, you have to have a knack for that. That has to be something. I mean, you can, if you like solving problems, then yes, you can be trained to learn the languages and to troubleshoot. But if your personality or your skill set isn't that, and it takes you, you know, it's very hard for you, very difficult for you, then that may be not the area where your skill set is. And, you know, we all, that's the thing in our society that is so hard to understand, why they want to lump everybody in the same group, say, everybody do this. You know, just like, for instance, everybody go get a 4-year degree. Well, for everybody, that's not the thing that will help you be successful. So you've got to find that. And that's the same with logic. Programming logic, this class will tell you really whether programming, you know, there's other areas of computers besides just troubleshooting and coding. And if you like that, then I mean, you need to learn everything you can learn and go and get some experience in that area. So these are things that people have to be willing also to learn on their own, be motivated to go out there, because everything is available now online where you can learn anything you want to learn. All right, so if we go back over to where this one is, this one, did anybody have any trouble with this one then? Everybody's got it running? Okay, so the next one that we're gonna do, oops, why did that one not come up? Oh, good. So the next one is understanding sequential statements in Python. And this is what we've been doing ever since we started, are called sequential statements. And they don't branch anywhere. We haven't done functions yet, or actually in chapter 2, unit 2, we talk about modular programming if you've read the whole chapter, but we haven't actually covered that in class because I was waiting till this test was over. And this is the last coding problem in 2, and it does not have modular programming in it. So in this lab, you complete the Python program that calculates the amount of tax withheld from an employee's weekly salary, the tax deduction to which the employee is entitled for each dependent, and the employee's take-home pay. The program output includes state tax withheld, federal tax withheld, dependent tax deduction, salary, and take-home pay. This is probably what your check stub looks like when you work. Jamie?
I have an issue with this one.
Okay.
Where it says, like, I would get it to run and it would give the stuff it's supposed to say.
Mm-hmm.
But if you go over to the checks,
You're missing
during
your
the checks,
point zero.
There's a 0.0
Uh-huh.
that needs to be added, and you have to add it in yourself. If you don't, it counts it wrong every single time you run the checks. And
Okay.
it gives you 3 or 4 specific numbers in its like actual checklist that you have to run it on. So like the salary input amount and the number of dependents, those are the specific ones.
Yeah, when you run it, you have to run it with the values they want you to run it with. Yeah, all of them from here on out will be like that.
The one thing that I was confused about is it doesn't tell you in like the actual like information for the problem to run it with $60,000 salary and 3 dependents and a $30,000 salary and 6 dependents. But if you go to the checklist and you look at
Right here, this is the first one.
Yeah.
Okay.
You have they're putting their own values on the checker. So.
Yeah, well, that's why we do them in class. So I'll show y'all. But if you do them ahead of time, yeah, you're going to probably have a lot of frustration because they have a lot of stuff. And I give you the exact one that they want in there. These are good problems. It's just that the way MindTap grades them, you have to do exactly what they're expecting, because the way a program works is it's checking character by character. Okay, so here's what it says: to write the code needed to perform the following. So I'm not sure how much of this yours started out with. Let's see. Does yours have this at the top? Okay, salary 1250 and number of dependents equals 2. Is that how yours starts?
Yeah.
Okay, so then it says to calculate the state tax here. So you have to actually put this one. Now, here's what I'm going to do that makes it a little easier. Is I'm going to put those. Oh my God, my text is really small here. Just a second, and I will show you what problem this is. This is 2, and this one is the payroll. So I'm going to open this one, and you'll be able to type it in from me showing you. Let's see, I don't want it in brackets. I will open it. And I did fix my pie chart too, where the text is bigger, so I can use pie chart. But this shows it a little larger. So here are things that are different. Did I tell you to? It didn't change it to input. Wait, I don't have the original. Hold on. I made some changes so that we could see what it looked like with input. That's why I did that. Okay, let me go back. Let's see when I changed that. Let's see, I didn't know I did change it. Oh, I did there too. It didn't tell you to change that to input, right?
Yeah, number 4 does. It tells you.
Oh, okay, that's why that's like that. Okay, so here's what what you should put in there. This one is state tax equals salary times, okay, this is the one for, here, I'll put it in there. That one goes there, and then it prints the state tax. Calculate federal tax here.
Did you, I think you put the wrong number. Isn't that supposed to be 6.5, not 0. No, that's the decimal form of the percentage.
Yeah, when the percentage has to have the 0 in front of it. Okay, so then this one is for federal tax. So the federal tax goes here. And then dependent deduction, oops. Yeah, you guys that try them outside of class, that's great practice. And if you can get it to submit 100, that's awesome. If you don't, then we'll be sure and go over it in class. But it is better, you'll learn it better if you do, like, I know Jamie and John been doing them outside of class. I'm not sure who else, but that's the way to do it, to really learn the material. Now calculate this one. There's what it looks like. And let's see, print dependence, then calculate. Oh no, I put that one in the wrong spot, didn't I? Let me see. It should go here. Is that withholding? Oops. That's where the withholding is. So the dependent deduction was in the wrong place too, didn't I? I see what I did. Okay, Command X. This one goes here. And this one goes here. They spaced lines between each one. Okay, so that should be where we're at so far. Then we got the take-home pay. So the take-home pay is here. And then these are the output. Okay, so the first time through, execute the program by clicking the run button, you should get the following output. So if I run it now, I should get, that one has, oh yeah, I see, it's not showing all of 81.25, and you'll notice what the 350 put all those zeros out there and a 6 on the end, because it's not formatted to only print out 2 decimal points. Then we have 62.5 and 1250 and 756.25. So our output is correct. Next, it says, in this program, the variables named salary and number of dependents are initialized with the values 12, 50, and 2. To make this program more flexible, modify it to accept interactive input for salary and number of dependents. So what I'm going to do is what was in my program over here. Oops, come on, idle, come back up. So I'm going to take the salary, and you'll notice what we haven't done yet is what is done here is using float. And that's because we're dealing with numerics, right? I'm sorry, with money. So there, I'm saying salary is equal to float. And you remember in the past, we've just been using int right there, right? Because we weren't dealing with money or any kind of fractional decimal point. Now, this will help you to remember when you take the test, how to do money. And you can look at these. You'll be able to go into your Cengage, because the problem that I'm giving you for the test is not one that's in the Cengage book, okay? So you're able to use this example. So now it's going to ask for input, and it says to make this, so here it says, you all are saying it makes you do specific, but I don't see where it tells you that.
It doesn't tell you, but it does run it against those 4 specific values that ask you to input.
Where does it ask you to input those?
It doesn't tell you.
It doesn't ask you to input them.
It's the
They
check.
input it. That's how they check the thing.
Okay, so if I go here. Okay, so right in here, 2 out of 2 checks pass, great work. Here are the test cases. So you will always need to do this, because see, they're telling you they can't, there's no way they can tell if your answer is correct without you using the same values. So even though we're asking for input, when we run it here, we have to go in, but see, they've already given 100% anyway. So
I think the issue whenever I was doing it is that it used float in the first 2, which that was probably why.
oh, up here. Yeah, and you didn't know to put float, right? Okay. So yeah, we won't have that problem, because in class I showed you to put float here for your input.
Where?
Up here, okay, and number 4, after you ran it with the values they had in there, then you put 2 input. You change the salary and the number of dependents into input.
I love Python. I'm having so much fun with it. Because I did not use the float, I used the int, and then I just timed it by 1.0. I totally did. Right?
Oh, but that's harder.
That's harder, but that's how I got it.
Yeah, see, if you wait, you should always use a float if you're dealing with money or fractional, like these decimal points here, because then it's going to know that it's dealing with a float number, because there's cases where that won't work. There's cases where the 0.01 won't work. If you're dealing with, you're multiplying times a number that has 3 or 4 decimal points out there, and it's not a money, then that won't work. In this case, it did, because it only needs 2 decimals here. Okay, anybody have any questions? So, yes.
Can you scroll down to the bottom for me, please? Scroll down to the bottom for me.
Oh, yeah. So this is actually the process you would go through to calculate your paycheck, right? This, all the things that you see on your, I can't think of what it's called, on your pay stub, is that you have federal tax. Of course, there's some more stuff taken out because there's Social Security, there's all kinds of stuff, right? That comes out of our paycheck. So, but this is the basics of federal tax, how much deductions you get for dependents, total withholding is state, federal, and dependent deduction, and then the take-home pay is what we always are interested in, right? It's the only thing that matters, really. Okay, so everybody got it? No?
And Stack Overflow, I don't like it. It shows you the hardest way of doing stuff, and there's easier ways of doing it.
Yeah, but Stack Overflow, there's some things that you'll use whenever you do. Cyber people use that a lot, Stack Overflow. But yeah, it is a little
So
hard.
that's what I used, and then
Uh-huh.
I didn't know I could put an input or float or any of those.
Okay, there's another one too. I think I put out there somewhere for W3. Did you get it, Lane?
Wait, what?
Did you finish?
Not yet. I'm still trying to do the flow.
Okay. Did you? There's what it looks like right there. Did you get it, Tom?
I'm trying. I just realized.
What you did? Okay.
We had to put in $30,000 in salary, right?
Yes, the
And the-
second test case, but it should have worked once you put float up here
Yeah.
without you having to put those test cases, but
Actually, I didn't even put that. And do we put comma in it or no?
no. I don't know why it put the comma there. So if you go out to a place called W3 Schools, has anybody ever used that before? Okay, W3 Schools lets you learn, like, see, here's SQL, PHP. It has Python right here, and it will have specific things like Python string data types. Okay, just a second. Let me see if I can find. I think it's here where, yeah, there's all the different data types, type X, and it should show you in here also how to format. But I always, when I want to know something, it may be Python casting, maybe what they call it. Yeah, there's float. I just Google like I did a minute ago when I showed you how to do certain things. Python syntax. Oh, that's the indentation. Okay, did you get it? What's your You probably don't have capitals where it goes. Inner salary, I think, was capitalized. Yeah, see, enter salary.
I had too many equal signs.
Too many equal signs. All right. Anybody else? Everybody got it going?
No, I'm trying to find out where. I feel like it's somewhere to spelling somewhere. Or capital.
Oh, colon, that's up here.
Oh, the space.
Right here, and then a space. That may be it. I'm not sure, but try that. Because you copied each one of these, right? And those were working before you changed this. Was this working when you had input? Did you run it once with this where it came up over here with?
No, that's my first time running it.
Okay, so you should be able to, I think it makes you run it once with just the values that were in there, the 1250 and the 2. Did it make you run it that way once and get your 100%?
Yeah, I have
I just got that quite a lot.
like 9. I have like 3. Where I have a table of 10.
So is it not?
They just like match it up.
Oh, yeah, okay, so does yours give you what you need or no?
Yeah, I'm just gonna do what I use.
Oh, okay.
It's like,
If you have, I can also give you this code. And then you can, if I go out to here and inside Canvas, I will, let's see, this one is the sequential statement. So I'm going to add a file. Okay, I think that one's called payroll. Let me see if I can find it. Oh, I guess I did not put it in here. It's not going to let me add it somewhere. Come on, where's payroll? Well, I know I had it in here, but it's not wanting to come up. Let me try this first. File. Why is it select? It won't. It's not letting me find that one. Put there. I don't know why. Come on. Okay, I'll have to add it later. I'll put if you can't get it in class, I'll put the actual payroll one here in Canvas. For some reason, it's not letting me do it at the moment, but I will put it there. And you can get the 100%. Okay, so what we're going to do now is we're going to finish looking at chapter 2 because I didn't finish the modular part of chapter 2 in the slides here, and then we'll do some problems at the end of the chapter. So we talked about named constants, and that's what but I told you we're not going to really cover this magic number. It's kind of confusing, and I don't care if you know that right at the moment. So, okay, let's go here. Performing, okay, like John was saying in that little visual video clip, it should have given you some things about arithmetic operators. But here are the operators that you will use in Python and most other languages too. So they're just, the only thing that's different is the asterisk. When you were in algebra, you learned the asterisk instead of the multiplication sign. Sometimes there was a dot, right, in algebra that was used. So every programming language, if you want to use multiplication, you use an asterisk. If you want division, it's always a slash. So used to, if you were doing division in algebra or whatever, you always use that little division symbol, which I don't even have on, isn't even on the keyboard. But if you were talking about a fraction, you probably didn't realize, you thought that was 5/6. Well, it also means 5 divided by 6. That's what decimals or fractional numbers are really division. So let's see. Oops, where did it go? Now I lost. Okay. So that's what the slash, the only way in Python that you can use division is with the slash. So rules of precedence, we did talk about this, I think, because I remember talking about it in class. And that's why, like when Jamie did her problem, to make sure that it did it correctly, she used parentheses. But if you know the order of operation and you understand left to right, the order of operations, multiplication and division are evaluated after the parentheses from left to right. Addition and subtraction are evaluated from left to right last. So if you don't have any parentheses and you have some big problem or long calculation where you say 5 divided by 6 minus 8 plus 10, and it keeps going, that's not really a good way to do it, but you can do it that way and use the order of operations and not put any parentheses. Oops. But it's always better to use parentheses, and then you don't have to worry about the order of operations. Okay, so here is a little chart that gives you the order. Samuel, you guys will have to do that after, because I'm gonna send y'all the payroll one, okay, and then you won't have to worry about it. Okay, so assignment. This is the assignment operator. The precedence is compared to other operators in this table. So this table, if you want to always have this as a quick reference, some of you, your memory is probably so good that you can just memorize this chart. But after you've learned a lot of languages and you try to remember these things, sometimes you may forget the order of precedence. And so when it's talking about, if you're asked a question on the test, what's the order of precedence? That's what this chart is. It shows you by the symbol, which is the highest and which is the lowest. And which one, how the associativity is what tells you which order from left to right that it's evaluated. So the integer data type, dividing an integer by another integer is a special case. Dividing two integers results in an integer and any fractional part of the result is lost. So that's the difference in using float values and using integers. Okay, if you use integers and maybe the number that you brought in was a decimal, maybe 1.2 times 8. Well, if you define 1.2, that variable as an integer, then it's going to chop the decimal off. It doesn't use it. Yes, Katar.
We should put brackets on it?
No, you should initialize it as a float. If you want to use the decimals in your calculation, then you
input and then
right. Yeah, like we did in that last one we did. So that's what it's telling you. It's truncated if they're defined as integers. A remainder operator, and this is the one that I was talking about, and John says in the video he explains it. It's called the modulo operator or the modulus operator, contains the remainder of a division operation. So if you say 24 mod 10 is 4. Do we understand that? So if what modulus means is divide it. So if I say 24 modulus, which is the percent sign, 10, the answer is equal to 4. So if I divide 24 by 10, I would get 2 with 4 remainder, right? So the modulus is the remainder. So if sometimes in a division problem, you're needing to know the remainder, then the operator you would use is called modulus. Any questions? Anybody used that before? I used modulus before? Okay. So when 24 is divided by 10, 4 is the remainder. That's all that modulus means. Then now we're talking about something that is this term, modularization, the advantages of modularization. Every language, programming language, has a way to modularize. In other words, if there's a task that you do more than one time, then you put it in a little small module. And in Python, those modules are called functions. In COBOL, they were called subroutines. Also, sometimes you'll hear them referred to as methods in C++, Java, those languages. They can be called functions or methods. And procedures, actually, some of the old languages like RPG that I programmed in that y'all will never have to see, they called them subroutines and procedures because back then, that was the very first initial concept where the concept of modules were started. Because when I first started programming in 78, they did not really care whether you used what was called structured programming. We had go-tos. It was called spaghetti code, and you'll hear about it in the book there. It talks about spaghetti code. And I had to take a lot of old legacy code that was written that way and pull out modules, because when you were doing programming with go-tos, you would lose track. If it was a 400-line code program, and it just said, go to here, go to here. Well, with modules, they're either encapsulated little programs that can run on their own, and they're either all at the bottom. In the case of C++, it lets you put them at the bottom. But Python, with Python scripting, you have to be sure that the modules are before they are called. So the way I tell students to do it is always put your functions or your modules at the top. And then when you start executing a Python program, the interpreter is going to ignore your modules until it sees a call to that module. And we're not going to see that right now, but you are in this chapter going to see how to create little tasks. And you will, in this chapter, our programs are so small that you're thinking, why would you do that? Well, it's just for you to see how modules work. We're not going to create a 200 or 300 line program, but we're going to see the concept and understand the concept that in the main portion of the program, you have to make calls to that function or that function is ignored. And that's what gets a little confusing. So we're just getting an overview of them here. We're actually not going to code modules in this chapter, but you are going to see in the flowchart and the pseudocode in the MindTap ebook, you are going to see where functions are used. So modularization is breaking down a large program into modules. It's called functional decomposition. And there's a lot of advantages to these, to using modules. It provides abstraction, paying attention to important properties while ignoring non-essential details and selective ignorance. Well, I don't know why they put it that way. But what it does is it allows you to say, okay, to solve this problem, I don't have to know specifically how to calculate my pay. I just say, calculate pay. So I can write a generic outline of solving a long problem, and then the actual routine, how much taxes are taken out, what the percentage is, how many deductions, all of that can be done in a separate routine. So my main program I can look at and it says, oh, that's what I'm going to do in this program. So it's like when you write an English paper and you write an outline of it, the outline doesn't detail the paragraph. It's just the outline so you get the idea in your head of what that paper is going to do. Well, that's the same way with programming logic. You can write an outline now because of modularization. And in very large programs, when I worked in industry, you could set up a project team to work on just one module that way. And then when they get it running, then it can be inserted into the main program. So there's a lot of advantages to modularizing. New or high-level programming languages use English-like vocabulary. One broad statement corresponds to dozens of machine instructions. So modules provide another way to achieve abstraction. Okay, I'm going to go back to where it actually talks about this in the chapter because there's examples that I like to go over here. Let me go down to there it is. Okay, so this is the one that we're on. So abstraction is the process of paying attention to important properties while ignoring non-essential ones. So like, for instance, you think of programming as always having to do with numbers and routines. But everything we do, and we talked about this since the first week, everything we do actually has a logical sequential steps to doing it. So if today we're going to do laundry and you needed to call Aunt Nan and you need to start a term paper. Well, here are the details of starting all those chores, but this was kind of like the abstract idea, the modules that it would take to do it. So here are the exact steps for doing the laundry. Pick up the laundry basket, put the laundry basket in the car, drive to the laundromat, get out a car with the basket, walk into the laundromat. I know nowadays everybody has their own, but used to you had to go to the laundromat. Set basket down, find quarters for the washing machine, and so on. So see all the details, but this is the general main is do the laundry. But I didn't have to think about all these steps yet, right? So you might list a dozen more steps. So abstract artists create paintings in which they see only the big picture, the color and form, and ignore the details. Abstraction has a similar meaning among programmers. And you know, how many of you think of yourselves? Have you ever been told that you're a big picture type of person? Anybody been told that? Okay, Jamie. So you have to work at thinking of the details, because that's how I have 3 children. I have my 29-year-old, he's a musician and he's a visionary and he sees big picture in everything. Well, I'm a programmer. I see details, and I ask, well, so how exactly are you going to do it? Well, you know, I haven't figured that part out yet. So there's big picture, and there's, and all of us, you know, I think I told y'all about that little fun activity. There's tons of those personality things out on the web that students have fun with. My kids, they're always doing different ones. When we have a family meeting, they're all trying to figure out what's the new character quality of the other one. And there's a website if you want to have fun or have it with friends, 16personalities.com. Have you ever heard of that? No, you haven't, Alex? Jamie has. It's pretty fun. There's simple little questions you answer about yourself, and it gives you this little animated character to what your personality is like. You might find out if you're big picture or not, if you haven't ever known. So likewise, some level of abstraction occurs in every computer program. 50 years ago, a programmer had to understand the low-level circuitry instructions. Remember I told you that when it was not that many years ago now. I always thought that when I got this age, I'd be really, really old. And I am pretty old. But when I started, I was in my 20s programming. Actually, I wrote my first program when I was 15. My dad was a programmer in 55. So we started programming at a young age. He tried to get me to be a computer science major, but I went to college back in the 70s, and you had to take so much math, and I did all of that. But then I decided, no, I'd rather be a teacher. When I got out after 4 years and couldn't make a living, I got into programming. Because teaching back then in the 70s, I'm telling you, you didn't make anything. We think it's bad now, but I made under $10,000 the first year I taught elementary school. Yeah, that was pretty bad, huh? Y'all couldn't live on that, right? I couldn't either. I had to have a part-time job. So then I went, so this is what I had to learn though. I had to learn assembler language and machine level language to be able to program. And that's what my dad, he would bring home wired boards, and he stuck the wires in certain holes, and that's what programmed the computer. And so I got to watch him do that. And then the first one I wrote was on a Systems 3 cards. There's the big cards that I did in college, but there was System 3, it was called, and they were little square cards, punch cards, and I had to punch them out after I wrote the code.
Are you talking about those little breadboards?
Breadboards?
Yeah, the holes on it?
Now, they don't have these kind of boards now. I don't know that you would have ever seen one. They were big panels that went into the side of the computer, and they had wires in the holes, because a computer back in the 50s, when it first, if you've seen any pictures, it would be as large as this whole top floor of this building, and it had vacuum tubes in it and wired boards. And I went, and one that large would only have 8K of memory. You know how much tiny, how little that is compared to the gigabytes of memory that our tiny ones have here, like this laptop. The chips are so small. So what's happened in the last, well, that was in the 50s up to the 70s. We didn't even have PCs yet until late 70s, early 80s. I forget when the first one came out. But anyway, those are things that have happened that has made programming where you guys have it made because there's debug programs, there's things that help you. And that's what it's saying here. In the past, you had to learn what was called low-level circuitry. And you engineers, you guys are going to know what that is, because you do program the circuits. So That's things that engineers do that are a little different than us as business programmers. We just have to know the high-level programming languages, which use English-like vocabulary. And COBOL, which it stands for Common Business Language, Common Oriented Business Language, something like that. It was real long, 5 acronym word. But it was actually long sentences, and as a programmer, I hated it because you had to have periods and commas, and it was like writing in a programming language in the English language. Script is the closest to like what old COBOL was, but it's nothing. You don't have to put the ands and the these, and just like you did in English language. If you look up an old COBOL program, you'll see what I mean. No matter which high-level programming language you use, if you display a message on the monitor, you are never required to understand how a monitor works. You don't have to know that because it's going to create each pixel on the screen. You write an instruction like output message, and it does it for you. So you didn't have to learn, like I was telling you the other day about CICS, is COBOL with assembler language is what created the screens that you did the data entry on. And you had to know how to write it was called map. Your screens that are drag and drop now, those were done with code, and they're still done with code. You just don't have to see them. Modules provide another way to achieve abstraction. For example, a payroll program can call a module named Compute Federal Withholding Tax. When you call this module from your program, you use one statement, and the module itself might contain dozens of statements. Just like the do laundry can contain 10 or 15 steps in the module, right? But the name of the module, you can just call it, and so you don't have to worry about coding that module at the moment. You just have to worry about what it's going to take to solve the problem. And that's what we're going to see, a template that we're going to use, that every problem has those certain modules. And that's what it's going to show you in the MindTap book. So modularization helps multiple programmers to work on a problem. So we learned one advantage was abstraction. Another advantage is what I was telling you earlier, that you can farm out some of the modules. You can say, hey, I have a real complicated module. I want to get down to the next step. So you go work on this module. When I worked in the banking industry, I worked in loans. And so I worked on a lot of project teams for installment loans and commercial loans. They all are calculated differently. And even back then, 98, we had the rule of 98. That was a different kind of an installment loan that they don't have anymore. So I had to know the calculation for that. A modularization also allows you to reuse work. So there's 3 advantages that we've come up to. So if you write a routine or a module for calculating federal withholding tax, every time you calculate a payroll check, you're going to need that. And so you reuse it instead of putting the code in your program 100 times. You just call it again, okay? So that is one of the other advantages to modules, is reusability. Reliability is the feature of programs that assumes if you've proven it to function correctly, then if you rewrite the code, you may make an error. So if you use the same code again that you've already tested, then it's more reliable. So those are the advantages there. So modularizing a program, here's how you do it. So we came up with 4 advantages. Now, how are we going to do that modularizing? Every program should be modularized for it to take advantage of the modularization. So here's the things that have to be in every program. Most programs consist of a main program, which contains the basic steps or the mainline logic. And so even like, you don't realize it, but in C++ and in Java, they have a function called main, but you don't have to do that in Python. You just start, it skips up there where you define a function. I'll show you that here in a minute. We'll look at it, or maybe not today. So every function, or if you call it a method, whatever you want to call it, has to have these three parts. A header includes the module identifier and possibly other necessary identifying information. So you can't have a module unless it has a name. And that's what a module header is. It tells Python that you have a function beginning. So skip over it until it's called. But you don't know how to call it if you don't give it a name. If you didn't have a name, nobody could call you out. I couldn't say Catan. He didn't have a name. So our function or our little routine, our module, has to have a name to be called. Then there's the body of it, which is the actual steps that you do in order to complete the task. And then we have to have a return statement. Python is real forgiving as far as return statements, but you should get in the habit of always putting a return, because what that says is return back to the main body of the program. Once you get through that task, return back to the main exactly where it was called from. Question?
Is it gonna end up like a loop?
It's similar, but you don't loop unless you run into that call, unless that call is inside of a loop in the main. But that's a good question. So return, what we're going to look at in the beginning are modules that simply return. They don't return any values back. They perform a task, and then they return back to the main. Okay? How many in here has written in other code before? Which one? Which language?
C+ and Java. I've had to reverse
engineer in
program.
C++?
Yeah.
Joseph, which one did you written in?
I wrote in Java and then I wrote in C.
In C? Okay. C#. Okay. So with all of those, you had modules that you looked at. And so you're a little bit familiar with what I'm saying. But the thing is, every module or every function, whatever the case might be, in this book, they call them modules because that's a generic term for all languages. Okay, so they may in a specific language be called something else, but they have the same function as a module. Okay, so naming a module is similar to naming a variable. The rules and conventions for naming modules are slightly different in every programming language. But in this text, module names follow the same general rules used for the variable identifiers. So what it's saying, when you learn a specific language, there may be details about those naming conventions that you have to learn. But as a whole, most languages, you're safe if you name a module with the same rules or the same guidelines as you do a variable. Module names must start with a letter and cannot contain spaces. So that's what I've told you with variable names, right? Module names should have meaning. So when you name a module, you want it to kind of give you a clue of what that module's, the task that it's going to perform, okay? So although it is not a requirement of any programming language, it frequently makes sense to use a verb as all or part of a module's name. What does a verb do in English? Show some action. See how important English is the rest of your life. You have to use it no matter what. But one good thing about programming logic is that you usually don't have to worry about the punctuation as much. You have to just learn that particular language's punctuation. So a typical module name begins with action words such as get, calculate, and display. When you program in visual languages that use screen components such as buttons and text boxes, the module names frequently contain verbs representing user actions such as click or drag. Additionally, in this text, module names are followed by a set of parentheses. Okay, so I know you all have all read this chapter, so I won't go verbatim, but I think there's some examples in the chapter that I like to, it kind of demonstrates things a little better. So here it tells you that most functions, and like when we're in Python, we're going to name our functions, and they also have a little declaration out next to them. And we'll see that here in a minute. When a main program wants to use a module, it calls the module. And that's what usually students have the hardest time realizing, is when they write the code at the top, it's ignored unless in your main program there's a call to it. And it's just a line of code. When we say call, it's just simply stating the name of the module.
Because I'm not 100% sure if the module I was to ask, is Python Pillow a module for Python, or is that like another program for Python?
I'm not even familiar with Pillow. So it would probably be, it may be a extension, like we're going to use random. It's probably a built-in function.
That's what I think.
Okay, every language, like in C++, they call it a library, huh?
Okay.
What? Yeah, in C++, they call it a library, and you include that library. In Python, like when we do the turtle program, we're going to have to include a module that's a built-in module, okay? So a module can call another module, and the called module can call another, just like I told you those three concepts that if we learn sequential, branching, and repetition, and a combination of all of those things, we can write any code. Well, modules can be nested inside modules. You can have modules called from inside another module. So those are things that we won't do in the beginning, okay? As it gets a little complicated. The number of chained calls is limited only by the amount of memory available on your computer. So in this book, the flowchart symbol used to call a module is a rectangle with a bar across the top. Now, let me show you one thing, and then I'm going to let you go. When you do that in Lucidchart, let me show you how we show a module. They don't have a shape that has a bar across the top like it does in our book. So what we use, let me just open this just to show you. So in the tools over here, what we use to show a module is not that one, it's this one, predefined process. So you'll notice it has the bars on the sides, where in our textbook in Cengage and MindCap, it shows a shape with a bar across the top. And in the old flowcharts or templates that I had to use by hand before we had this kind of software, you drew around it. It used the one with the bar across the top. But Lucidchart uses this one. So when we start coding flowcharts with the predefined process, that's the same as a function or a module. Okay. All right. So we're done for today. If you have any questions, now remember the test will be in here at 9:30. You'll have till 10:45. I actually give you till 11 to drop it in there, but you'll have to leave the classroom if you take that long. Okay. See you guys on Wednesday.
Yeah.